Alrighty, so quick little lesson here for multiplying and dividing fractions. Also, we'll be adding and subtracting fractions. Most of these skills are very similar. Just at any time you need to get some clarity, pause the video, all right? And you can get some clarity. Anyways, let's start here with number one. We have multiplication. For multiplication, the rule is to go straight across, okay? Multiply straight across. And of course, you can do this if you have two fractions. Fraction should have a numerator and denominator. Because the rule is to multiply straight across, we'll do 3 times 1, which is 3, and 4 times 2, which is 8. Now, is this my final answer? I hope so. In order to determine if this is my final answer, I have to check for a GCF between 3 and 8. So 3 is just 1 times 3, and 8 is 1, 8, 2, and 4. As you can see, they have nothing in common other than this 1, okay? So if we divide by 1, it doesn't change a thing. So smiley face, we are done with this problem. We do not use 1 as a GCF value, okay? So that's why this is the final answer, because there's no GCF. Moving on to number 2. For number 2 here, we got multiplication between 11 and 20 and 2, which is 22, and 5 and 11, which is 55. But instead of me taking this 11 times 2 and 5 times 11 route, I'm going to cross out my 11s, because I have 11 at the top and 11 on the bottom. That is going to simplify for me. All right. Sometimes multiplying can make the numbers bigger prematurely, when in reality, this is the situation. We can cross out the 11s, and it's going to leave us with our answer, 2/5. And again, you always ask yourself, is this my final answer? You check and see if you have a GCF. In this situation, 2 and 5 will not have a GCF. Moving on to number 3. For number 3 here, we got some multiplication to do with the 6 and the 5. That'll give us 30. And then we got 9 times 18, which is 162, according to my calculator. Now, yes, this is a big number. It can be intimidating to break down, but you can do it. All right, let's start with 2. I can chop both of these guys in half. That'll give me 15 over 81. And now that I'm looking at it, I'm like, maybe I can go a little bit further. 15 and 81, I can divide both of those by 3. If I divide them both by 3, I should end up with a 5 up top and a 27 on the bottom. Again, just using my calculator, I can get this, okay? So because we divided by 2 and we divided by 3, I'm pretty sure the GCF for 30 and 162 is 6. 3 times 2. If we just divide this by 6, we could skip this one and go all the way here, okay? We can go all the way here. Now I'm going to do this problem in another version. Maybe you'll like it, maybe you won't. Instead, I'm going to expand 6 to 2 times 3. This is called prime factorization. When you break numbers down to their tiny little pieces, we're going to look at 9 as 3 times 3. 5 is just 5 and 1, so there's no need to really do 5 and 1, but whatever. And last but not least, 18 is 2, 3, and 3. Literally, 18 is 2 times 9, and 9 is 3 times 3. So 2, 3, and 3 is how we get 18. If I put this all in one term, just one fraction, I got a 2, a 3, a 5, and a 1. A 2, 3, 5, and 1 up top. On the bottom, I got 3, 3, 2, 3, and 3. My rule is to cross out anybody who's at the top and the bottom. So there's 2 right here. I got a 2 at the top, 2 at the bottom, gone. Also, I got a 3 up top, 3 at the bottom, gone. 5, that's the only one left here. 1, no one's at the bottom. And it looked like we're left with 3 3s. So 5 times 1 gives me 5. 3 times 3 times 3 gives me 27. Again, if you don't like this style, don't use it, all right? It's just another way to kind of get to a simplified answer without the numbers getting so big. I know this seems big for a lot of you, but hey, you can handle it. You got it. We got calculators. Anyways, moving on. Let's move on to division. For division, we use this thing called keep, change, flip. Because in fact, we do not divide fractions. We do not divide fractions. We always multiply. It is our job to make sure that we change dividing to multiplying using the keep, change, flip situation. So here's my keep. My keep is 3 over 4. I keep everything exactly the same. My change is flip. My change is changing division to multiplication. My flip is changing 1 over 2 to 2 over 1. Then we follow our same rules as before, straight across. 3 times 2 is 6. 4 times 1 is 4. And again, we go through that same progression as to, is this my final answer? It's not. You can divide both of these by 2, which gives you 3 over 2. This would be your final answer. Again, if you have any questions, just press pause and ask yourself the question. Or even better, when you're in class and you have a question, ask the question. Moving on to number 2, we got a whole number divided by a fraction. All whole numbers can be turned into fractions by dividing by 1. 5 divided by 1 is 5, so I didn't change any values. Let's go ahead and employ our keep, change. I'm going to use the dot this time. Flip. Now when I multiply, I get 5 times 11, which is 55. 1 times 2, which is 2. And GCF, probably not. I can't divide both of these by 2, so this is my final answer. And last but not least, another keep, change, flip situation. 18 over 5. Calculator, we end up with negative 162, just like the problem we did above for number 3 on multiplying fractions. On the bottom, we should have 30. The GCF for these two would be 6, okay? I promise you. You can divide both of these by 6. We went over that already with this problem here. You will end up with negative 27 over 5. Easy money. So again, we do not divide fractions. We do not divide fractions. We change division to multiplication using the keep, change, flip. Moving on to adding and subtracting. Rule is you can only add or subtract when denominators are the same. Denominators have to be the same in order to add and subtract. So when I'm looking at number 1, the denominators are the same. They're both 8. Good. Because both of them are 8, it's going to stay 8. And we just do 3 plus 2, which is 5. Final answer? Yes, it is. Unless you can simplify. If denominators are the same, you just add and subtract those numbers up top. Right here, my denominators are the same. So 11 minus 4 is 7 over 15, simply because they are the same. Is this simplified? Yes, it is. All right, again, a little fancy here, a little extra work, but hey, the denominators are all the same. So calculator 1 plus 3, we end up with 4. And then we're going to do 4 minus 2. 1 plus 3 is 4, and then 4 minus 2 is 2. Question is this the final answer? Of course not. Divide by 2 on both sides, you end up with 1 over 3. Simplified answer. That is a simplified answer. Let's move on towards the back. For these, we do not have denominators that are the same. Clearly, 3 is not 9. But in a rare situation, I can change a 3 into a 9. And you'll realize it's not that rare. If I multiply 3 times 3, I'll get 9. What you do to the bottom, got to do to the top. The new problem becomes 3 over 9 plus 4 over 9. Because denominators are not the same, we just do 3 plus 4, which is 7. Feel free to pause, rewind the video to get some more clarity, and ask questions in class. Now we get to number 2 here. I'm looking at 2, I'm looking at 6. Now I'm like, can I change that 2 into a 6? Absolutely. Times 3, times 3. The new problem becomes 3 over 6 minus 1 over 6. Let that sink in. 3 over 6 minus 1 over 6. Denominators are the same, so we just do 3 minus 1, which is 2. Is this my final answer? Of course not. You can divide them both by 2 and get 1 over 3. And if you think I'm wrong, send me a little message. Tell me in class, hey, I think you got number 2 wrong. And we'll talk about it. All right? We will talk about it. Anyways, moving on. Got a lot going on here. We got 7, 4, and 14. Can't change a 4 into a 7. That's not gonna work. Can't change a 4 into a 14. So I gotta do some fancy stuff here. I have a way of making 7 look like 4. I have a way of making 4 look like 7. Watch this. If I give 7 a 4 and I give 4 a 7, they look the same now. Isn't that something? If I give 7 a 4 and I give 4 a 7, they both look the same. They both look like 7 times 4. Wow. What you do to the bottom, you gotta do to the top. If you didn't know, that's 28, y'all. That is 28. Is there any way that we can get this 14 to look like a 28? Treat it like Blue's Clues. They like, yeah, a 2. Yeah, multiply this bad boy by 2. And we all in now. All the denominators are 28. How do you do this? With skill, y'all. It's called least common denominator. We'll get deeper into that later. The new problem becomes 6 times 4, which is 24, over 28, minus 7 times 3, which is 21, all over 28, minus 2 times 1, which is 2, over 28. 2 times 14, 28. So in my calculator, the only thing I'm focused on is 24 minus 21, which is 3. 3 minus 2. 3 minus 2 is equal to 1. 1 over 28. And you know that's simplified. No GCF for 1s. Again, if any clarity is needed, play the video again. pause and pull the cursor back so you can see and hear what just happened. Get you an instant replay. But for now, I'm moving on. That's it? Nothing else to move towards? Oh, man. Anyways, that lesson I want to give you guys as far as finding the least common denominator. Least common denominator is going to be the smallest number or variable that one or more numbers or variables divide into evenly, okay? When you're finding the least common denominator for some numbers, what you want to do is you want to write their multiples, okay? Multiples. If I do the multiples of 2, we're talking about 2, 4, 6, 8, 10, 12, 14, 16, and so on. You can go on forever. When we're talking about the multiples of 6, we're talking about 6, 12, 18, 24, 30, 36, etc. Go on forever and ever. Last but not least, we got 12. 12 multiplies 12 times 1 times 2 would be 24, times 3 would be 36, times 4 is 48, times 5 is 60, not 16, but 60, and so on and so forth. What we're looking for is the number that they all have in common, the smallest one that they have in common. I see that 12 here, I see that 12 here, and I see the 12 here. So if we want a shortcut for finding the least common denominator, we should focus on writing the multiples of the big number. That's just my opinion. All right, because clearly these smaller numbers, you get a lot of them. You get an abundance. Some people are going to feel more complete by finding, breaking down the multiples for all the numbers. Do what floats your boat, okay? Right here for the variables, it says look for the variable with the highest exponent of power. That's going to be your LCD. This guy right here is going to be our LCD. Simply because we can give him 2 x's and we can give him an x to catch up to this guy, which we don't have to make any changes to the least common denominator, okay? But we would have to change x to x to the third and x squared to x to the third by contributing a certain amount of x's to complete the task. Again, look at the highest exponent value to determine your least common denominator for variables. And now you mix those rules together. I'm looking at these numbers here. We can multiply all of them to 12 and get everybody here to x to the third. The least common denominator is going to be 12 x to the third. So I can turn 6x into 12 x to the third. What would 6 need? 6 would need to multiply by 2 to get to 12, and the x would need 2 more x's to get to x to the third. Easy money. 12x squared, in order for it to make it to 12x to the third, it will need an additional x. It does not need a number. It already has a number. It just needs an additional x. And last but not least, 2x to the third. What does it need to make it to 12x to the third? It needs very little. It already has x to the third. We just got to change the 2 to a 12 by multiplying by 6, okay? Again, we're trying to find the least common denominator to do the least amount of work. We don't want the numbers to be so big, okay? And, of course, we'll get more practice in class with our prep work, CFUs. Maybe be ready for a quiz. I would say mid to late Monday class session, okay? Not at the beginning. We'll spend most of that time reviewing. Some of you may be ready to quiz on this upcoming Friday. Hey, whatever's available, just make sure you're ready to do your best. Signing out.